Welcome everyone, Math 105, this is Lesson 20, Mixture Applications. So we're going to be studying some applications where we take different varieties of things and mix them together. And to see how this is going to work, we're going to look at the value of some coins. So let's say we were been saving money for a while and putting our coins into a piggy bank, and now we're going to see how much we have. So we open it up, see we have 47 quarters, 38 dimes, 52 nickels, and 159 pennies. We're going to find the total value. And to find the total value of a number of coins, we take the number of coins, multiply the value of one of those coins, and then we get the total value. And so this table represents that calculation. All right, we get the number, here's the value. If we multiply these two together, we get the total value. So of the quarters, we got 47 of them. They're worth 25 each. Multiply both those two numbers together, and the total value of all the quarters is $11.75. You can do the same thing for dimes, nickels, and pennies. And then, once we get the total value of each of the types of coins separately, we're going to add together in this column to get the total value. So keep those two operations in mind. Multiplying straight across, and then in that last column, add to get the total. Because those are the two operations we're going to be doing when we set up tables for problems. For example, we've got $3.20 in dimes and nickels. We also know that we have 5 more dimes than we do have nickels. And so we're going to take this information, plug it into this table, and we're going to be able to figure out how many dimes and nickels we have. All right, so first of all, let's write in the value of one coin. For a dime, they're worth 10 cents each. For a nickel, they're worth 5. And now the only thing we know is that we have 5 more dimes than nickels. And so what we can do is define a variable for nickels, because the number of dimes is given in terms of the number of nickels. So if we create a variable for the nickels, we can create an expression for the dimes using that variable. And that's going to be the trick in solving these. So let's say n is the number of nickels. Now to find the number of dimes, we're going to use those translation skills that we were working on for the last couple of lessons. We have 5 more dimes than nickels. So we have more dimes than we do nickels, and there are 5 more. So if we start with the number of nickels, and we add 5 to it, that gives us the number of dimes. And so now we have expressions for both the number of nickels and the number of dimes, and I can plug that in for the number here. So nickels is n, dimes is n plus 5. And that's really the tricky part of doing these. The rest is very straightforward. Now we're going to do exactly what we did over here. Multiply straight across. All right, so we're going to multiply 10 times n plus 5. Make sure you put the n plus 5 in parentheses. And then multiplying straight across here, we get 5n. And now we've got a column here that we can add together. We're going to add this plus this equals the total. Because this is the total value of all the dimes. This is the total value of all the nickels. Add those together, we get the total value of all the coins. All right, so we get 10 times n plus 5 plus 5n equals 320. And there's the equation we can solve. All right, so I'm going to start by simplifying on the left. So distribute and remove the parentheses. So that's 10n plus 50 plus 5n equals 320. Now we can add the n's together. 10n plus 5n is 15n. I'm going to continue on over here. And I'll subtract 50 from both sides. That gives us 15n equals 270 divided by 15. And it equals 18. And n is the number of nickels, so that means we have 18 nickels. And since we have 5 more dimes than nickels, that means we have 23 dimes. $18 and 23 dimes. Now let's check to make sure that these add up to $3.20. So 18 nickels, they're 5 cents each, so that's 90 cents in nickels. 23 dimes, 10 cents each, so that's 230 cents in dimes. 230 plus 90 is 320, so that checks. Now your turn number 1. This one's a little bit trickier because we've got 3 different types of coins. Malcolm has 440 in quarters, dimes, and nickels. He has 3 times as many dimes as quarters, and he has 4 more nickels than dimes. How much of each coin does he have? So if you want a hint in how to set this up, you have to read this very carefully. We have 3 times as many dimes as quarters, so we're telling the number of dimes in terms of the number of quarters. And then nickels is given in terms of dimes. So we're going to express nickels in terms of dimes and dimes in terms of quarters. So we're going to have to start with quarters and create your variable as the number of quarters. So I'm just going to use Q for quarters. And now you need to create expressions for the number of dimes first, and then the number of nickels. All right, so if Q is the number of quarters, how will you write 3 times as many dimes as quarters? All right, we need an expression in here for dimes. So what's 3 times as many quarters? Times is multiplication, so 3 times Q, or 3Q. And now for the nickels, we have 4 more nickels than dimes. Well, this expression here represents the number of dimes. Now, how would you write 4 more than that? 4 more than is addition. 4 more that would be plus 4, 3Q plus 4. So there's the 3 expressions for the number of coins. All right. Now, just like we did before, we're going to multiply straight across and fill up these 3. So 25 times Q, 25Q. 10 times 3Q, that's 30Q. And then 5 times 3Q plus 4. So this is where we need the parentheses. And there are 3 expressions for the value of quarters, the value of the dimes, the value of the nickels. Now this still gives us the value of dimes even though we have Q in it, because it's all just based on the number of quarters. We're calculating the value of the dimes from the number of quarters. And same thing here for the value of the nickels. All right, now what did we do before? We added up this column to get the total. So that's the same thing we're going to do here. We're going to add these 3 things together to get the total 440. And now we can simplify on the left. $25Q plus 30Q, that gives us 55Q. And then I'm going to distribute in here. Distributing gives us 15Q plus 20. Now we can add these Q's together, so that's 70Q. Now subtract 20 from each side. So 70Q equals 420. Divide by 70. and Q equals 6. Now we use these expressions to get the number of dimes and nickels. So we have 6 quarters, and we need 3Q. 3 times 6 is 18. So that gives us 18 dimes. And then nickels, we have 4 more than the number of dimes. So that's 22. All right, now we need to check. So 6 quarters at 25 cents each is $1.50. So that's 150 cents. And for dimes, 18 times 10 is 180. And then for nickels, 22 times 5, that's $1.10. Or 110 cents. Add them all up and we get 440. So that is correct. 6 dimes, or 6 quarters, 18 dimes, and 22 nickels. All right, next type problem is the mixture word problem. And these are used in all sorts of different types of fields, from financial planning to chemistry. So, first example is can be used to set prices at a grocery store. So what we're going to do is use this formula, number of pounds times the cost per pound is the total value. So let's say we're buying some nuts that cost $5 a pound, and we want 2 pounds of them, multiply them together, 10 bucks. And that's going to be the main equation we use, and the table we set up is going to reflect that equation. All right, so what we're going to do is we're going to take some hamburger, combine it with some ground sirloin, and get a mixture that's somewhere between the two prices for the hamburger and the ground sirloin. So a butcher would like to create 150 pounds of a ground beef mixture made up of hamburger, which sells for $2 per pound, with ground sirloin, which sells for $3.60 per pound. Now the butcher would like to combine these so that the mixture will sell for $2.50 per pound. So we're trying to figure out how much of each type of ground beef should be used. All right, so what we don't know, the two unknown quantities, are the amount of the two types of ground beef. So it doesn't matter which one we choose to be the variable. I'm just going to say H for pounds of hamburger. All right, now we know that the total weight of this mixture is going to be 150 pounds. So to find the amount of ground sirloin, we have to take the total amount and remove the hamburger. So we remove by subtracting. So it's 150 minus H. Is the pounds of ground sirloin. So if we have 50 pounds of hamburger, we take 150 minus 50, we'd have 100 pounds of ground sirloin. So when we add them together, it's 150. Now we know the cost per pound for all three of them. The hamburger is $2 per pound. The ground sirloin is $3.60. And we want the mix to be $2.50 per pound. So the number of pounds, that's going to be filled in with our variables. So H for hamburger. Number of pounds of ground sirloin is 150 minus H. And then we know that the mixture is going to total 150. And if we add these, they should add up to 150. H plus 150 minus H is 150. Now total value, we're going to find that in the same way as we did last time, multiplying straight across. Using our formula, number of pounds times cost per pound equals the total value. So when we multiply straight across, we got H times 2, so that's 2H. 360 times 150 minus H, so that's 3.6. And then 150 minus H in parentheses. And now we can multiply here, 150 times 2.5. $3.75. I know this one's going to be a little bit different in that the total value of the mixture is already given. So we don't need an extra column, or we don't need an extra block here. Because if we take the total value of the hamburger and we add the total value of the ground sirloin, that's going to equal the total value of the mixture. We combine them together, total value. All right, so we're going to take 2H plus what's in this block equals 375. And there's the equation we need to solve. So I'm going to distribute first. All right, now we'll combine like terms, so 2H minus 3.6H. All right, now I'm going to get all the numbers to the right, so subtract 540. So we have negative 1.6H equals 165, or negative 165. Divide each side by negative 1.6, and we get H is just about 103, or round to 103. So that means we need 103 pounds of hamburger. Then we'll subtract that from 150. So we need 47 pounds of ground beef. All right, 103 pounds of hamburger and 47 pounds of ground sirloin. Your turn number 2. The manager of a grocery store is creating a bean mix for making soup. The mixture will consist of black beans, which cost $2.50 per pound, and red beans, which cost $3.50 per pound. how much of each type of bean should be included to produce 60 pounds of a mix that will cost $3.25 per pound? It doesn't matter which one we create a variable for. I'll just do B for black beans. Now the total is going to be 60 pounds, so the number of red beans, or the pounds of red beans, will be 60 minus B. All right, the total minus the amount of black beans is the amount of red beans. So for black beans, the number of pounds is B. Red beans, 60 minus B. And the mix, we know that's going to total 60 pounds. Now dollars per pound, that's given. 2.5 for the black beans, 3.5 for the red beans. And we know the mix is going to cost $3.25 per pound. Now to find the total value, we'll multiply straight across. 2.5B, 3.5, we'll distribute that into 60 minus B. And then here we got 60 times 3.25, that is 195. Now we can create an equation out of this column. The cost, or the total value of the black beans plus the total value of the red beans is the total value of the mix. And so there's the equation we need to solve. So I'm going to start by distributing. Now combine 2.5b minus 3.5b. So that's negative 1b, so 210 minus b equals 195. And negative b equals negative 15, so divide both sides by negative 1, we get b equals 15. So we need 15 pounds of black beans. And then for the red beans, we'll do 60 minus 15, or 45. Pounds of red beans. Probably can't read that. 15 pounds of black, 45 pounds of red. Your turn number 3. Heather's putting in a rock border around her garden, and she's going to use a combination of polished and unpolished rocks. She needs 260 pounds of rock, and she can spend $2 per pound. The unpolished rock costs $1.60 per pound, and the polished rock costs $4.80 per pound. How much of each type of rock should she purchase? So we got unpolished rock, polished rocks, and the mix. So we know the cost per pound, $1.60 for unpolished, $4.80 for polished, and we want the mix to be exactly $2 per pound. So we're getting polished and unpolished rock. We know that the total is going to be 260, so 260 goes here. So I'm going to define U to be the amount of unpolished rock. And so if we're getting 260 total, and we want to know the amount of polished rock, we have to subtract the amount of unpolished rock. So that's 260 minus U. Now we're ready to multiply straight across. So U times 1.6, that's 1.6 U. And here we're going to do 4.8 distributed into 260 minus U. And here we do 260 times 2, that is 520. All right, now we've got our last column, so now we can add these two together. We're going to add the value of the unpolished rock with the value of the polished rock to get the value of the mix. And there's the equation we need to solve. So we're going to distribute in. And now we can combine like terms, so 1.6U minus 4.8U. So that's minus 3.2U. And now I'm going to get all the numbers to the right by subtracting 1248. So we got negative 3.2U equals negative 728. Divide by negative 3.2 on both sides, we get U equals 227.5. So if we got 227.5 pounds of unpolished rock, we'll take 260, subtract U, and that gives us 32.5 pounds of polished rock. Our last type of mixture problem is going to be investment mixture problems. And with these, we're going to mix together different types of investments just the way we mix together beans and pounds of rock and things like that. Now our main equation this time is going to be a version of the simple interest equation. We're going to use I equals PR. Notice there's no time because the time is always going to be 1 year. So we don't need to include that. Example 4. An investor puts $30,000 to work in two accounts. The first is a CD, which pays 2%, and the second is an annuity, which pays 5%. All right, we're taking $30,000, splitting it up into two different accounts. We got the CD, and 2% as a decimal is 0.02. And then we have the annuity. At 5% or 0.05. So we use a slightly different version of the table, pretty close though. So you got a row for the CD, a row for the annuity, and a row for both. That's kind of like the mixture. So for the CD, we know that the rate is 0.02, the annuity is 0.05, and now for both of them together, we're targeting a rate of 3.8%. And as a decimal, that is 0.038. Now we do not know how much is going into the two accounts. So that's what we're going to be solving for. So just like before, we're going to define a variable for one, and then write an expression for the other using that variable. So it doesn't matter which one we pick, CD or annuity. I'm just going to say CD. C represents the number of dollars in the CD. Now, if we know the total amount invested is $30,000, and we're splitting that up amongst the CD and the annuity, if we put a certain amount into the CD, to find the other amount, take the total and subtract what we put into the CD, 30,000 minus C. So notice this is just like the other ones. So 30,000 minus C represents the number of dollars in the annuity. So I'm going to put in C for CD and then 30,000 minus C for the amount going into the annuity. And both together, we know that we're putting 30,000 into both. All right, now we can multiply straight across using principal times rate, and that will give us the income. So the operations are just like for the other tables. So multiplying straight across, C times 0.02, that is 0.02 C. And then this one, we're going to distribute 0.05 into 30,000 minus C. And here we'll do 30,000 times 0.038, and that gives us 1140. And now we've got filled up last column. We can do exactly what we did before. All right, this is the income. So the income from the CD plus the income from the annuity equals the total income from both. And we can create an equation out of this. And there's the equation we need to solve. So we'll start by distributing. So 0.05 times 30,000 gives us 1,500 minus 0.05 C is 1140. Now we can combine like terms. 0.02 C minus 0.05 C. That gives us negative 0.03 C. All right. Let's get the numbers to the right. So negative 0.03 C equals 360, or negative 360, my bad. Divide by 0.03 on both sides, and we get C equals 12,000. So 12,000 goes into the CD. We got a total of 30,000, so 30,000 minus 12,000 is 18,000. So $18,000 goes into the annuity. Now to check, let's figure out how much interest we'll make on both of these individually and then add them together. So go 12,000 times its interest rate, 0.02, get an amount of interest, and take 18,000, multiply by 0.05, get another amount of interest, add those together, and make sure it equals 1140. It's very easy to make a mistake on these, so it's essential to check. Your turn, number 4. Avery and Caden have saved $27,000 toward a down payment on a house. They want to keep some of the money in a bank account that pays 2.4% annual interest, and the rest in a stock fund that pays 7.2% annual interest. How much do they put into each account so that they earn 6% interest each year? So we're given this column the 3 rates. The bank pays 2.4% interest, so that's 0.024. Stock fund, 7.2% interest, so that's 0.072. And both together, they want to earn 6%, so 0.06 for both. Now I'm defining B to be the amount we put in the bank, so principal for there is just B. Now we know we're putting 27,000 in, split up amongst both of those accounts. So the amount left over for the stock fund after putting B in the bank is 27,000 minus whatever we put in the bank. And then both together is the total amount invested, which is 27,000. Now we're ready to multiply straight across. 0.024B there. Here we're going to distribute 0.072 into 27,000. Minus B, and then here 27,000 times 0.06, they want to earn $1,620 in total interest. All right, now I've got our last column filled up, so we're going to add together the interest from the bank and the interest from the stocks to get a total interest of $1,620. And there's the equation we need to solve. So just like with others, start by distributing. .072 times 27,000 gives us 1944. Now we'll combine like terms, 0.024 minus 0.072. Get 0.048B equals 1620. And we'll subtract 1944 from each side. negative 0.048b equals 324, or negative 324, divided by negative 0.048 on each side, and we get b equals $6,750. So we'll take the total amount, $27,000, subtract $6,750, and for the stocks we get $20,250. Your turn, number 5. This one's a little bit different. An investor puts the money into an account that earns 6% interest. Then the investor put $5,000 less than the first investment into another account that earns 4% interest. The total interest earned over 1 year is $3,000. How much is invested in each account? So we're not told what the investments are, so just first account, second account. And the first one pays 6%, so that's 0.06. The second one pays 4%, 0.04. Now we don't know how much is invested in the first account. So I'm just going to call that a variable X. And the second account, we don't know how much that is, but we do know that it's $5,000 less than we put in the first account. So less than means subtraction. So we'll take whatever we put in the first account and subtract 5,000. So that is 5,000 less than what we put in the first account. Now we know already the total income. It says the total interest earned over 1 year is 3,000. So that goes in the total income column. And now we're ready to multiply straight across. Remember, we don't even need to fill these in because we're already given this number. So don't make things harder than they need to be. Fill in what we need. Now we'll multiply straight across, get 0.06x here. And here we get 0.04 times x minus 5,000. Now we've got our last column all filled up. That's all we need. So we will add up the income from the first investment plus the income from the second investment equals the total income. And there's the equation we need to solve. So just like with the others, we'll start by distributing. Now we can combine these, 0.06x plus 0.04x, so that's 0.1x. Now we'll solve for x, so let's get the numbers to the right. So I'll add 200 to both sides, I'll get rid of the 200 here. 0.1x equals 3,200, divided by 0.1 on each side, and x equals 32,000. So 32,000 goes in the first account, and we know there's 5,000 less in the second account, so subtract 5,000 from this, and we get 27,000. Sorry, 27,000 in the second account. So problems like this, they require a bit of practice. And the hardest part, usually, is creating the expression. So once you get that down, the rest is fairly basic. And it follows the same pattern each time.